Well, hello and welcome to this exercise on scale drawing, scaling, standard form, indices, and some measurement. And I think it's suitable for iGCSE, certainly foundation level, and GCSE and grade 9 and GED, I think, GED as well. Now, it's been sent to me by T, and essentially we're supposed to find the distance between two towns or cities in the United States, from New York to New Orleans, and from El Paso to Miami, and from Seattle to Denver. But because I don't want to do your homework for you, I'm going to do from New York to El Paso. That's from there to there. But the method is the same. It doesn't matter if you do go from New York to New Orleans, or from El Paso to Miami, or from Seattle to Denver. Right, two columns, one for paper and one for real life. Now, over here we got our scale measurement, 1 to 50 million. Now the 1 will be under paper and the 50 million will be under real life. Okay, so now we have 1 centimeter to 5.0 times 10 to the power 7. Now I've expressed this here in standard form because there's too many zeros there. So instead of doing that, I've written down 5.0 times 10 to the power 7. If you check, we got 7 zeros there, so you got 10 to the power 7. And secondly, if I had measured in millimeters, then that would be in millimeters as well. So the units must be the same. Right, now next, I measured from the point here, which I think is New York, to the point there, which is El Paso. And my measurement is 8 centimeters. So 1 centimeter on paper is equivalent to 5.0 times 10 to the power 7. Therefore, 8 centimeters on my screen or on your paper is going to be 5.0 times 10 to the power 7 times 8 centimeters. And that's the measurement. Now, we need to change these centimeters to meters first, and because we know that there are 100 centimeters to 1 meter, so if we divide that by 100, now 100 has got 2 zeros, that's 10 squared, and we've got 10 to the power 7 there. So if you divide that by that, and because you're dividing indices, you subtract the bottom from the top, so 7 minus 2 will give me 5. So my answer should be 5.0 times 10 to the power 5 times 8 meters. Now we need to change that from meters to kilometers. And there are 1,000 meters in 1 kilometer. So we divide all that by 10 to the power 3. And as before, because we're dividing, we do 5 minus 3. So we end up with 5.0 times 10 squared times 8 kilometers. And when you do some calculation, you end up with 4,000 kilometers. And that's the form the answer is required there. But I've done some extra work here. If you want to change that from kilometers to miles, you divide your 4,000 by 1.6 and you get 2,500 miles. Now that's a bit longer than what National Geographic says is the distance from New York to El Paso. I'm about 300 or 200 miles out, but it doesn't matter because the method is correct and your measurement should be more accurate than mine. But you know, the method is okay. Right, next slide. Right, now on this slide we've got an aeroplane, and this time round we are given the distance in real life. And it says the actual length of the aeroplane shown in the scale drawing is 64 meters. And I'm assuming they mean from there, from that tip to that tip there. And it says find the scale used in the drawing. Okay, now to do that, as before, we're looking at paper and real life. Now, on paper, I've measured 10 centimeters. That's from there to there. That's on paper. Now, in real life, it measures 64 meters. And because there are 100 centimeters in 1 meter, I have to change that to centimeters because the units must be the same. So 10 centimeters on paper is equivalent to 6400 centimeters in real life. That's from measurement there. Now we need to change that to 1. So if you divide 10 by 10, so because you divide 10 by 10, you must also divide 6400 by 10. And if you do that, you end up with 1 to 640. So the scale is 1 to 640. Again, mind you, my measurement may not be as accurate as yours because I'm measuring on screen here. You'll be measuring on paper. So that will be the difference. Right. Now, next, we want to find the actual wingspan of the aeroplane. And so looking at the wingspan now, the wingspan is measuring from tip to tip of the aeroplane. So that's the wingspan. Right. Now the scale we've got is 1 to 640. So again, 2 columns, paper and real life. Now on paper, I've got the scale is 1 centimeter to 640. That's the scale. So if I measure 1 centimeter, that's 640 centimeters. But I've now measured from this tip of the wing to that tip of the wing is 9.7 centimeters. But it may be wrong, but I'm sure that's what I got for my measurement. And your measurement will be more accurate than mine because I'm measuring on screen, you're measuring on paper. So my 9.7 on paper will be equivalent to 9.7 times 640 in real life because we know that the scale is 1 to 640. So now we need to change that to meters. So we divide by 100, divide that by 100, and I got 62 meters approximately. I hope that makes sense. Now please pause the video and go back and have a think and do it again. Right, now we want to find the actual width of the fuselage. So we're looking at fuselage now, and the fuselage is the width of the fuselage is from there to there. The length of the fuselage is from there to there, and that's the width from there to there. And again, 2 columns, paper and real life. Now we know that the scale is 1 to 640, and I've measured 1.2 centimeters to give me the width of the fuselage. So if I multiply 1.2 by 640, that will give me the measurement in real life, and that should be 640 centimeters in real life. Now if we then divide that by 100, we end up with approximately 7.7 meters for the width of the fuselage. And I hope all that made some sense, and please subscribe. Thank you. See you again sometime. Bye bye.